If you search for linked lists in Google, these are the images that will pop up. The main idea or concept behind the linked list data structure is the word linked, where basically nodes are just connected. So what are linked lists? Before we talk about linked lists, let's have some sort of an overview of what data is. Computers are basically machines that process data. You can imagine data as anything from words, or texts, or numbers that needs to be organized. In code, data is frequently managed by lists or array. But let's forget about this very abstract explanation, and let's understand these things, data, array, lists, in a more creative approach. For the sake of explanation and for the sake of giving an example, let's say we own a warehouse. And this is a top view of our warehouse. But for our explanation, let's simplify it with a line art. So here's our top view. The square lines are the wall of the warehouse. And let's put a door on the top left corner. And then let's hire a robot as our warehouse employee. And with this, our warehouse is now ready for business. Let's say a customer wants to store the data 1, 2, 3, 4 in our warehouse. So in order to store it, let's say that we make a room for the data storage. Then we add extra walls to partition that room into 4 parts. And then we partition it further so that we can create special rooms for the storage of the data. And then we add our doors in that room so that our robot can go inside. And now we can start storing the data. So what happened here is that the robot carried the data inside the storage rooms, and the robot passed through the doors and just placed the data. So this method of storing data is what we call as a list or array data structure. The data are stored just like how lists are in real life. Let's say we got another customer who wants to store the same data, but this time we're going to store them in a different way. Let's say we create another room. But instead of doing it something exactly the same as the first one, we change the door placement. Notice that since the door placement is changed, the robot has to necessarily go through the first room in order to store data onto the next room. And this type of data storage or strategy for storing data is what the topic of this video is about. This strategy of storing data is what we call as a linked list. A linked list is a data structure where the storage spaces are linked together and relies upon the first storage space in order to access all the data within that storage. In a more abstract way, it is visualized like this. Notice that the storage spaces for the numbers or for the data 1, 2, 3 are connected through a link, and the last connection for 4 is just connected or linked to an empty space. And if compared to a normal list or array, normal arrays are visualized just like this. Notice that there's a difference. And if this data structure is compared to a normal list or array, it is very different because an array or a normal list just is visualized just like this. In software programming, linked list is very advantageous because adding or removing storage is just easy and doesn't require much time, since it can be added on the empty pointer or in this case, in our door. Whereas in a normal list, in order to add or remove storage, it can be sometimes hard because the computer, or in our case the robot, has to go through all the storage spaces. And that's just what linked lists are. The storage spaces are connected through a link, or in a more technical term, uh, these storage spaces are connected through a pointer. And now, since we understand what linked lists are, there are different subtypes of or different types of linked lists. One example is the singly linked list, which is basically just what the example earlier was, where the pointer points one way. And there's the doubly linked list, where there are two pointers that points both ways. Another example is the circular linked list, which can be visualized like this circular storage room. But technically, it can be visualized like this. It's just like what a normal linked list are or what we talked about earlier, but there's a pointer, the end pointer loops back and points back to the first storage. And there's this more complicated linked list, which is the skip list, where it is just in computer science, it's a probabilistic data structure that is built upon the general idea of a linked list. The skip list uses probability to build subsequent layers of linked lists upon an original linked list. And then lastly, then there's this more complicated and sophisticated ones, like the unrolled linked list that basically looks like this. And it's just in simple explanation, it's just a variation of the linked list which stores multiple elements in each node. And that's just it. Linked list is basically just a data structure for collecting data. It stores data or it organizes data in a very different way compared to normal data structures like lists or arrays. And now, since we understand linked lists, let's look at some real life applications. A popular example of linked lists, of how linked lists can be used, is the back and forward button in our web browser. Let's say we want to search for meaning of words, so we search for dictionary in Google. Once we arrive at the result page, data is created. Then let's say after the search result page, we click for the first result. So another data is created, and now we are here at the web page of dictionary.com. Then let's say we want to search for more words, so we search for red. And now we're here at the web page for the red definition. And so a data is then created. Then we search for more and we search for green. Then we are now here at the web page for the green definition and the data is created. And then we search, keep on searching, we search for blue. And then let's say we want to go back. So we go back to the green web page. And what happens here in our linked list is that when we go back to the green data, since all this data here is stored in a linked list. So in order to go back, the computer simply just goes back here to the green one. So it goes back to the green web page. And then let's say we are back at the green web page, we search for another word. Let's search for the word white. And then what happens is that when we're on the white web page, data is created. And since we are already on a new web page, let's say here in our example, the white web page, what happens or what the computer does is it just breaks the link for the blue storage. And this is what happens in a linked list in this particular situation. And this right here is just one of the uses of a linked list in computer programming. Another example is the undo button, which works similar to the back and forward button in the earlier example in a web browser.